All right, guys, so we are here with IS number 14, which is about confidence intervals for day 1. Obviously, we'll have day 2 next week. So the first part is about guessing the mystery mean. I'm trying to make this relevant to you. So if we were in class today, you would be making your best guess at the mean of the midterm exam scores. So the ones that we just took right before, or I apologize, right after spring break. By creating a confidence interval. This is something new to us, but it tells us right here that a confidence interval is the point estimate plus or minus, that's what this symbol with a plus and a minus sign here means, so plus or minus the margin of error. If we were in class, the group who creates a confidence interval with the smallest margin of error that still captures the true mean exam score will win a prize. And we'll see what that means later, although unfortunately no prizes. So number 1 says that I will give you a random sample of 5 scores, and I would normally, and I just want to show you where these scores would come from. So I have an Excel document here where I have put a number 1 through 28. That's how many students are in my 2 stats classes at this time. And then I listed all of the exam scores next to them. So here's a full list of exam scores. Okay, so you can see down there I did calculate the mean, but we don't need to know that yet. We're just imagining that you get a sample of 5 of them. And so I had 5 random numbers generated. Notice I put ran between up here. That generates a random number. So I have 5 random numbers generated, and I chose those scores, which those are actually different random numbers than the ones that I actually ended up putting, or that I'm going to put on our paper. But let me give you 5 scores that we can work with. So the first one, let's see how I get here. The first one is 65. And then 100, and then 88, and then 84, and 90. Okay, yes, so there we go. We have 5 scores, just random scores that I selected. I'm gonna stack my paper so I can write more clearly. That we randomly selected to look at it, and we're going to try to use these 5 scores to give us an estimate for the entire class. So the first thing to do is find the mean. Since I just have 5 values, I'm actually going to use the definition of the mean, add them all together, and divide by the total number of values. So 65 plus 100 plus 88 plus 84 plus 90. If I had a longer list of values, I'd definitely enter them into a list and do one variable statistics, but this isn't bad. So I get 85.4 is my mean. So I'm going to enter that right here. 85.4 is my mean. So because this is my sample mean from my sample of 5 scores, I'm going to use this as my point estimate for the true mean. Your textbook goes into a little bit talking about how the sample mean or the sample proportion is the best point estimate because there are other possible values that we can find. And it explains in previous chapters why, but we're not going to go into all of that. We're just going to say your sample mean, or later our sample proportion, is going to be the point estimate for our true mean or true proportion. So the next thing we need to do, and this is a regular thing in these problems, is identify the population parameter, sample, and statistic. So the population we're looking at here is from this Excel file, right? What did those represent? Oh. Those represented midterm exam scores. And right there are listed all of the midterm exam scores. So our population is all midterm scores. And we could be more specific, and we could say for Professor Bacula's Intro to Statistics class this semester, but this summarizes it nicely. So all midterm scores. Now the parameter that we're interested in from that, right, is the measurement that we're taking based on the population. So we're interested in the mean, but because it's based on the population, it's the population mean. And hopefully you now know that the notation for that is mu. And again, that is representing our true mean score. Again, mu is the population mean. We have to get the symbolism right here. Okay, so then we need to know what sample we have, and for us it's just those 5 scores. So we're going to write that they are the 5 midterm scores. It's very important to get all of this clear. And then the statistic is the measurement that we take based on this sample. So if you remember, the notation for that was our X bar, and again that represents the sample. Actually, I'm just going to write it next to it. That represents the sample mean score. Sample mean score. So true is for the population, sample mean score is just for my sample. Okay, so now we're going to take that point estimate and turn it into an interval of values, right? An interval of values by adding and subtracting the same number. It has to be the same number from your point estimate. And the number you add and subtract now is called your margin of error. This is some new vocabulary. Okay, so margin of error is important. And next I would ask, what margin of error would you choose and why? So there are a couple of options for this. You could choose a large value like 10. I'm going to add 10 points to the mean and 10 points subtracted from the mean to get an interval. So it'd be about 75 to 95. There's a pretty good chance that we capture the class mean if we make an margin of error that big and interval that large. But that's a lot of possible values. That's 20 points worth of possible values it could be. Most of us like to be a little bit more specific than that. So I'm going to go with the value that my students from last year used. So they wanted a margin of error. Margin of error. Now they wanted a margin of error of 2. Now before we move on, I do want to introduce to you the symbolism for this. Of course, there's a symbol. So the notation for this is capital E. Your book uses this. Sometimes books use MOE as the abbreviation, but your book just uses E, so I'm going to stick with that. All right, so margin of error of 2. Let's choose that. So that's 2 points either way. And it did ask us why, so I'm going to give an explanation. We just wanted a small interval. Okay, so let's go ahead and think about how to find that interval. We have to add 2 to our mean that we found up here and subtract it. So I'm going to start by subtracting 85.4 minus 2. And then I'm going to add 85.4 plus 2. That is going to be my margin of error. So if I work that out, let's see, 85 minus 2 is 83.4, and 85 plus 2 is 87, so 87.4. Okay, so that's my new interval. I've changed my point estimate now into an confidence interval. So it says, write your interval that you think contains the true mean midterm exam score. That's exactly what we just did. 83.4, 87.4. Notice I'm writing this in interval notation. I'm writing the bottom limit. Your book refers to this as the confidence interval limit up to the top limit. And I separate them by a comma, and then I put parentheses around them. There are a couple other ways that we could have written this. I'm going to write one more here. We could have written 83.4 is less than P is less than 87.4 to indicate that P is supposed to be between those two values. And your book does use this one at first and then shows this one a little bit later. Okay, so we're leaving this space over here so that we can write our interpretation of that. We're going to come back to it in a minute. But I want to go ahead and talk about how confident you feel that your interval captures the true mean and answer with a percentage. So keep in mind that we only took a sample of 5 out of all 28 students. And we don't have a very large margin of error, right? 2 is not that large. So I probably am not 99% confident. I don't think I'm that good. I would say maybe more around, 70, 80, something like that percent. So I'm going to say maybe 80. Now with this question, I'm just asking you to get a feel. Later we'll move on to more precise reasons for choosing our percentage, but this is just kind of getting a feel for why we would even say 80% confident. So our next question says, one of the groups got 71 to 79, where 71 is their bottom confidence interval limit and 79 is their top confidence interval limit. So what was their point estimate? So this is asking us to work backwards. Well, we know that to find our interval, we had to add and subtract the margin of error to get our bottom and top limits. So we can work that backwards and try to find the midpoint between them. So to find the midpoint between them, we're essentially just going to take their average. So to find the point estimate here, we're going to take those two values. Let's see, it's 71 plus 79 and divide by 2. Find their average. Okay, so 71 plus 79 and then divide by 2. 75. And maybe you could have seen that without actually working it out, that 75 was the midpoint between them, but I wanted to show you how the calculations work if you do have more complicated numbers. So their point estimate must have been 75. I'm going to show you over here, when I did this before, another sample of 5 numbers that I got was this 88, 84, 63, 68, 74, and the sample mean resulting from that was a 75.4. So that's a perfectly plausible interval that could have happened. So now let's figure out what their margin of error was. We know 75 must have been their point estimate. So some of you can already tell that the margin of error must be 4, but I'm going to show you how to actually calculate it. So remember, margin of error is denoted as E. So we take the upper limit and subtract the lower limit, 79 minus 71, to find out how long the interval is, and then divide it by 2. So we get 8 divided by 2, that would be 4. Another way to do this is to take the point estimate and subtract the lower limit, you get 4, or the upper limit and subtract the point estimate, again, you get 4. Lots of different ways to make that. Those simple calculations there. But here's a nice formula for us to move on with later. Okay, so I am going to claim, aka I calculated it, let's see, that the mean exam score, let's look back up here, this final cell says 76.03, blah, 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 I'm going to round to 76. So the true mean exam score is 76. So does your interval, and I'm talking about the one that we calculated based on the mean of 85.4, using that as our point estimate here, we got this interval. Does that interval support or deny this claim? So the question you have to ask yourself is 76 within the interval of 83.4 to 87.4? The answer is no. So no, because 76 is not within my interval. Okay, all right, so this is this testing a claim. When we're given a value that we think the true mean might be, we can compare it to our interval. Now, conversely, if you had been the group who had 71 to 79, your interval would support the claim of 76 because 76 is within that interval. You can't say for sure that that's the true mean, but it would make sense based on your interval. Okay, so I'm going to go back in and add a few extra things. One thing that we really need to be able to do is interpret this confidence interval. Like, what is this actually telling us? So I'm going to give you a standard way to do that. So we have this interval here. We are going to say we are blank % confident. Okay, and that % confidence will be whatever % is given to us for the confidence interval. Here for us, it's 80. I'm going to fill that in a minute. That the interval, so we are blank % confident that the interval from blank to blank, whatever your limits of your interval are, that interval captures the true, and this is where I want to fill in my parameter of whatever the context is. It's going to be a little bit longer for me. Okay, so for us, we thought that this is about an 80% confidence. So I'd say we are 80% confident that the interval from 83.4 to 87.4 captures the true, and this is the parameter, so the mean of, and then the context, the midterm exam scores. Okay, that's our interpretation for the confidence interval. We're going to write that on the big ideas on the back as well. That's a sentence that you need to know by heart from now on. All right, let's also write down some formulas for finding the point estimate. So I'm going to abbreviate point estimate to be P.E. I can find the point estimate assuming that my interval is A to B. I can find that by adding A and B together and then dividing by 2. On the other hand, I can find the margin of error by subtracting B minus A and then dividing by 2. Okay, so I think that's about it for that front page. I'm going to make a second video for the big ideas on the back and then the check your understanding.